Okay, what we're going to do today is we're going to do a test run on recording this video for the Boy Scouts, talking about contours and how they work. Okay, what we have here is some elevation data. This is the basis of how I'm going to show you how contours work. This elevation data is digital. It's collected outside by flying an airplane over the area with radar or laser information bouncing off the ground and telling how high every point is. If you look at this, a point on this map, the elevation, the pixel value, is 2,252 feet above sea level. Let's zoom in a little bit on this so I can show you how this works. So what we're going to do is we're going to color all of these pixels for each elevation with a unique color. So you can see that from this elevation data right here, that every one of these little squares on this elevation data set is assigned a number for the elevation. You can tell when you look at this that there are these bands. These bands each represent a certain level or a certain elevation above sea level. Let's go back and return this to what it once was. So as you see here, there's two areas. One Inyokern over here and one Owens Peak over here. Now I'll tell you right from the start that the area on the right, this Inyokern area, is much flatter. And as you can see by the color here, this is the lowest part, and this is the highest part of this square, and this is the lowest part going to the highest part of this square, based on the color that it assigns, this software assigns to the elevation. So what I'm going to do now is I'm going to switch over to another software where I have the same data sets loaded in, but these data sets in this software are rendered by the computer into what they call a hillshade. Hillshade is a computer-generated representation of what the ground would look like based on the elevations if the sun, in this case, was coming from the north. We can do a similar kind of thing we did with the other software and show the lowest elevation in dark blue to the highest elevation as you get up in here to the oranges and towards the reds. So you can see that this is the lowest part moving across the data set to the highest areas being up here. Let's return this to what we call the daylight shader in this software. Okay, so what we have here is an area that is on the eastern side of the Southern Sierra Mountains. This is the desert area out here. You can see, if you look carefully right here, these lines, this is actually the Inyokern Airport. This is a road coming up here. There's another road, and you can see the interchange of the two roads and the on and off ramps. Another road comes here. And so when we open up the Google image, I want you to kind of understand where we're looking. I'm going to bring in this Google Maps image. So here's the same airport we were just looking at, the same interchanges on the roads, the same mountains over here. So you can kind of get a context for where we are located. Now let's real quick, before we go any farther, tilt this view in Google so you can see a little bit of what this area looks like in the perspective of, let's say you're close to the ground. So what we have here is, looking to the west, we have the mountains, and looking to the east, we have this flat area heading out towards the city of Ridgecrest. Okay, so let's, from this point, let's jump in here and see what it looks like when you're actually on the ground with a photograph. So there's looking west towards the mountains, and there you are looking east. You can't see very well over this little berm, but east, it's very flat out there. So now you have a context for where we're going to contour. Now, a contour line is a line of equal elevation. So what I'm going to do is I'm going to, in this software, which is called Global Mapper, I'm going to generate contours, and I'm going to generate them 20 feet apart. Let's go 50 feet apart so it'll be a little faster. 50 feet apart. And I'm going to do it only for an area from here to here. So now what we're going to do is wait for a minute while this software generates contours for this area. Now, if you want to think of a contour, think of the edge of a lake as the water declines in a lake, as we've had a lot in California recently, and you see the shoreline ridges from the waves. Those lines of equal elevation, are what these lines and the contours on the map will represent. So when we're all done with this, what we'll do is we'll look at the same area in a USGS topo map. Okay, so these lines are completed. So let me draw your attention to this. If you stood at this point on the map, down here at the bottom, on this cyan or light blue colored line, and you wanted to walk north, but never go uphill or downhill, if you would follow this line, you would stay at an equal elevation all the way along. Okay? Another thing you can see is out here on the flat area, the contour lines are far apart. So when you see a USGS topo map, excuse me, when you see a USGS topo map where the lines are far apart, that means there's less slope. And the closer the lines get, there's more slope. Let's go back to our map here, or our elevation data set. It's in Google, and so you can see this a little bit better. So what we're going to do is look at that same area, and you can see that over on the right hand side here, the elevation is pretty flat. The slope has a low slope, but as you start heading up the mountains over here, the slope gets steeper and steeper, and as you head up higher on the mountains, you see some of these mountains have much steeper slope. Let's go back to Global Mapper. So what we're going to do here, the first thing is I want to call your attention to this area right here, where you can see that the contours are very close together, and out here where they're far apart. Now what we're going to do is we're going to grab a tool called a line of sight, or a path tool, and I'm going to go like that. What this does is it creates a profile of what the elevation does along that line. So the elevation goes from about 2,200 feet down, or 2,300 feet down here. It's relatively smooth up until about the area where the road is, and then all of a sudden it gets much steeper. All these little marks that are on this map are the contours. So you can see that on low slope areas, the lines are far apart. On steep areas, the contour lines are close together. Now, let's dismiss this and look at this in 3D. So what we have here is the same area we just contoured, and the lines are over the top of the hill shape. Now, I've exaggerated this to 3 times. If you look at it 1 time exaggeration, it seems a lot flatter than, seems a lot flatter. But so you can see what's happening here, we'll go up to 3 times vertical exaggeration. That means we're stretching things vertically. So if we go in close here, let me get rid of this. If we go in close here on this map, you can see the same thing we were talking about before, where on the flat area out here, the contours are farther apart, and when you get up here along the mountains and it gets steeper, the contours become closer together. One more item to show you how this works. I'm going to turn on this function here, and what this does, this floods the area. So what we're going to do is we're going to come in here, and I'm going to start with the water level about 2,300 feet, and I'm going to go in 50-foot increments. Let's zoom back a little bit. So let's say this valley had flooded and the water was going to be rising. Let's move this up here just a little bit so you can see this. So as every time I cause the water level to increase by 50 feet, you see that it floods up to the contour line representing that 50 feet. Now, there's a little detail along the edge here where the contours smooth themselves out when they're created, but you get the idea. So as the water level keeps rising, it keeps flooding more and more up to each contour level. But you can see that it doesn't move that much farther towards the mountains with each one of these lines. In fact, right here it's going to start moving, it's going to get deeper faster because the slope increases so much more on the mountains. Okay, I hope that helps you understand a little bit about how contours work. Now let's go back. I'm going to close this for a moment. I'm going to turn off these contours, and I'm going to turn on the USA topo map for this area. Now this seems like it's going to take a little while here. And we've already into this about 12 minutes. So I think what we're going to do is end it right here and maybe pick it up again once the contours draw in. Okay, we took a little pause while this data drew in. So this is what you would sometimes call a quad map or a USGS topo map. This map is used and developed by the government. And one of the key pieces of information on this map, in addition to the roads and airports and all the other stuff, are these elevation contours that you can see. So if you're going to go hiking, you want to see what a trail does, you can tell that down here at the mouth of this canyon, your trail will have a certain elevation, and as you go up the canyon, you'll get higher and higher as you go up the mountain, and you'll be able to tell by those lines what the elevation happens to be. Now let's see if we can look at this in 3D, so you can see this USGS topo map put into 3D, just like the other map we had. Okay, so this gives you an idea of how these maps are made. I'm going to reduce the scale of the vertical to 2 times, but you can see how these maps are made. They're used, somebody goes with the elevation data and traces on the ground the elevation, whether it's in a computer or by hand, and then creates a map which shows not only the elevation features, but information that you might need for hiking or for the direction where physical features like roads and canals run. And it also shows information about land division, which are these numbers here. I hope that helps you, and I hope you enjoy learning about this. If you're interested in learning any more about this software, Colleen can give you an idea of how to contact me. I'd be happy to answer any questions. Thank you.